There is one more law that I want to talk about before I do an example. It is known as law of sines. Again, it involves the all three sides of the triangle and the angles. Let's take a look at law of sines and what it looks like. So if I have a triangle, for example, in this case, here I have a triangle. Let's say this is side A, side B, side C, and let's say this angle in front of this side is, say, alpha. In front of side B is beta, and let's say this angle is gamma. All right, I have three sides and three angles, and if I have all that, then I can write the relationship involving the sides and the angle, and that would be sine alpha, which is this angle, over the side in front of it, opposite side A, would be equal to, say, sine beta over the side B and sine gamma over the other side. All right. Now, if you look at this relationship, there are four quantities here, two angles and two sides at any time. And if you know three of them, you can find the other fourth. This is a very simple formula, and I'm not going to spend time proving this. You can actually verify this yourself. So a combination of law of sines and law of cosines will help you to solve any problem involving vector addition or subtraction and so on. All right, let's take a look at an example. All right, here's an example where we want to use an analytical approach in solving a vector problem. In this particular case, take a closer look at this problem. There are two forces applied at this point. Let's say we call this point A. Okay? Two forces. There's a 3 kilonewton force. That would be 3,000 Newton force applied about 60 degree from the vertical line. And there is another force, 2 kilonewton, applied at 40 degree from the vertical line in the other direction. We want to add this. In other words, two people are pulling this rope, and how is the resultant is going to be? The net effect of these two forces. So in order to do that, instead of using a graphical approach, I'm going to make a quick sketch. So it may not be drawn to scale, but it's going to look something like this. Here's my first vector, 3 kilonewton. That's point A. And then I'm going to draw like a triangle law. Remember, here is my vertical. From the vertical at 40 degree, I draw the next force, which is my 2 kilonewton. So this is 3 kilonewton. This is 2 kilonewton. And I have my two forces. So the resultant force, as you can imagine, by the way, this is going to be my resultant, right? This is my resultant. And I want to find out the resultant force. So this is what I want to find out by adding these two vectors. So let's mark all the angles that I have. You know this angle is, I'm going to use a different color so you can see this. This angle is 40 degree. So if I draw a horizontal, this angle is going to be, as you can see, is 50 degree. I hope it is clear, right? Now, remember this angle, this looks like almost this is my vertical line. So from the vertical, this one is 60 degree as given to me. So this angle should be 30 degree. So this will be alternate angle 30 degree. So what I have is this angle is 50 plus 30 is 80 degree. Now let me draw one more diagram so you are not confused with all this information. This is my 3 kilonewton force. And this is my 2 kilonewton force. And my resultant is this, all right? And this angle we figured out as 80 degree. So we need to find out my resultant force, which is this R, as well as probably these angles, all right? And this is my horizontal line. So how do I find these angles? This angle I can call it as, say, alpha. Let's say this is beta. All right. In order to calculate these angles, I'm going to use my say law of cosines. If I want to use law of cosines, remember r square, I am writing just the magnitude, equal to 2 square, which is this side, plus 3 square. By the way, if you forgot this formula, I'm going to write this on top here. R square equal to p square plus q square minus 2 times p times q times cosine, say, theta, the angle between. So I'm following this. R square equal to 2 square plus 3 square minus 2 times 2, which is that 2, times 3, which is this 3, times cosine 80 degree. And that's what this 80 degree is. All right. Now, this is something very easy to evaluate. And once we evaluate, we have to take the square root of that. Remember, r would be the square root of all of this. And if I did that, my vector r happens to be 3.3. And make sure you give the units at the final answer, kilonewton. All right. You can verify this by yourself by solving using this formula. So we got the resultant vector's magnitude. What is missing here is the direction. In other words, we need to provide where is this vector originating from. In this case, I would say this vector from my horizontal line goes this way. So I want to find this angle. But I do know this is 30 degree, but I need to find the alpha. So how do I find this alpha? Well, if you recall, we have used law of sines. If I use law of sines, it is going to be sine alpha using the side against it, which would be in this case 2 kilonewton, would be equal to, I know this 80 degree, sine 80 degree divided by the magnitude of r, which I found out as 3.3 kilonewton. Now you have a simple expression in which the only unknown is on the left hand side, alpha. So I can rearrange and solve for alpha. And if I did that, alpha is equal to 36.6 degree. Please verify this yourself. So alpha is 36.6 degree, and therefore the total angle that we want to refer is 30 plus 36. So my value of r, the final answer is 3.3 kilonewton at, and I can specify this angle as 66.6 degree. And that would complete the solution process of finding the resultant vector by adding p and q. All right, I hope this is clear. This is 66.6. And we got that by finding this alpha and adding it to 30 degree. All right, so that completes an example where we are using both law of sines and law of cosines to find the unknown side and the unknown angle. I hope this is helpful, and there are numerous problems in the book, and I suggest you try some of them.